Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
Hello everybody. Tonight, as promised many weeks ago, I promised we would be in the new studio, and that has come to light. There's a lot of equipment and we're just learning how to use some of it and incorporate it into the show. And so we'll be doing some live in situ filming, and then some of it will be captured and shown in the studio, like right now. Just did a recent visit to the Yucatan Peninsula, where I've spent a lot of time in my life from the time I was very young. But tonight's show is going to be about space radiation. So you might wonder, well, what do ancient archaeological sites in Yucatan Peninsula of Mexico, what do they have to do with space radiation? And actually, they have quite a bit to do with it. It'd be very interesting. And I didn't know this when I was wandering around the jungles when I was maybe 24, 25 years old. But this became incorporated into my life as I studied physics, as I studied space radiation, and actually became somewhat of an expert in this. And it's also something I can tell you that NASA and all its staff of scientists really don't have any clue of what's going on in space. And unfortunately, from what I can see with SpaceX, the same situation. They just have no clue what's out there, what the problems are. I have a book on this. It's what I call the weather book, the Principia Meteorologica, the physics of sun-earth weather. And by the way, these books are written for the general public. That title is in Latin, and the Principia Meteorologica. In other words, principles of meteorology. But the ancients saw these events in the sky. They saw them and they recorded them. And what we'll look at tonight, I'm in the background is a wall at Chichen Itza, one of the main sites. And it is dedicated to not the sun, not the moon, but the planet Venus. Now you think the planet Venus, that's that little white dot up in the sky. It's brightest object in the sky next to Jupiter and the sun. But and those are commensurate. Jupiter and Venus are commensurate. But why would the ancients have anything to do? Why would they study or pay homage to Venus and build all of these temples, etc.? And so behind me is one of the walls. And right now we're looking at one of the cenotes. A cenote is in the limestone, and this is common also in Florida area. That's why they have the sinkholes in Florida. But in the Yucatan Peninsula, there's a lot of limestone, and what happens over the eons of time, the water drips through and carves out these holes, basically, and then it contains the water down below. And very pure water. When I was young, I walked into one. It was in a cave, just like this one. It was not the same one that we're seeing now. But I walked in, and it looked like little fish floating in the air. And it was like, but the water was so crystal clear that you could see the fish swimming around, and it was so clear they literally looked like they were floating in air. But the cenotes were a source of life for the Mayan Indians who lived in this area. A lot of their descendants still live there. When I was young, I crossed the road from what is now Cancun. Cancun wasn't even there, 1972. 71, 72 timeframe, the Cancun wasn't even there. And there was one little wooden hotel at Puerto Morales. And then they had just built a new road made out of seashells going down to Tulum. And with a group of people, I was one of the first people, literally the first people to cross that road. You can still see the road next to the freeway as you go between Cancun and Tulum. There's off to the side, that road is still there. And so anyway, but water, fresh water, was the lifeblood of these people who lived a sustenance living in the middle of the jungle. Now Tulum, which I'll show in a minute here, was a port city, but going back to Chichen Itza now. Now we're at the main pyramid in Chichen Itza, and this once again is dedicated to the planet Venus. And along the stair casings going up to the top are a snake-like structure that at the bottom there's a large mouth and a tongue sticking out, and it represents Quetzalcoatl, the plumed serpent god of the night sky, who in their mythology was the planet Venus. Now, there again, Venus today is this little dot up in the sky. But in the days of the early Maya, now there were two Mayan cultures, one that flourished, estimated around 800 AD, but there were the pre-Mayas, and we don't know very much about them other than they left a very rich tradition, and that was carried on for thousands of years, much like the Christian religion today has been carried on for thousands of years by tradition and in writing and in legend. And so the Mayans honored Quetzalcoatl, a plumed serpent god of the night sky, whose heart eventually became the planet Venus. And this is one of the biggest bones of contention in modern science, is that they don't understand how this happened, and that's why the physics that I developed for the plasma discharge comet model and space radiation show why in ancient times Venus was a large comet, and it eventually settled into its orbit today because of the tail drag. Okay, so now you're seeing the connection between ancient archaeological sites and space radiation. So that's the main topic tonight. And so I'm going to talk about, I've already talked about space radiation on this program. And of course, it's contained in all of my books and literature that's available to the public. But tonight, what I want to talk about is taking this from a human perspective. Okay, so let's go back to the office and look into this in a little more detail. I wanted to give you a view here of, this is at Tulum, and you see the structures that, look at the doorway in this building. It's about maybe 4 feet tall. The people were very small, and the Lacandon Indians, who are the descendants of the early Maya, are very small also. So back in it's like 1971, I was in this area, just like I say, exploring, and one day took a walk in the jungle from Tulum to a little Lacandon village, which was nearby. And the people were literally 4 feet tall. The men were, and the women were even smaller. And their arms were like, they looked like little birds. That's how small these people. So I looked like a giant. And I am not big compared to a lot of people today. There's a lot of people much larger than me. But I was like a giant there. And I'll tell you a story that was very interesting. I went there, and they welcomed me with open arms. They're very friendly people. And they did not speak Spanish, and I did not speak very good Spanish at the time. But they did not speak Spanish, and so we really communicated kind of like by sign language. And so these men brought out a bottle of homemade mezcal. Mezcal is a alcoholic beverage made from a cactus plant, like tequila, but mezcal is a little bit different plant, but it's a tequila-like cactus plant. And they offered this to me. And so I had to take a drink, and that was like welcoming me into their community. And at the end of the day, I went over, and this lady, little short lady, like I say, she looked like almost like a bird. She was so small and her arms so delicate. And she had a little store there. And so she was selling bananas and other fruits, coconuts, etc. The only product from the modern world that they had there was condensed milk in a can, so I bought one of those. And as I'm standing there, her little shop, and it's all made out of materials, local materials from the jungle, and a little roof over it. And as I'm standing there, I looked up, and above her head was a quetzal bird. Now, a quetzal bird is a bird of paradise. And when this was about sundown, and I was about ready to leave and go back to my camp, where we were camping at Tulum on the shoreline, which is now the big tourist area that you see. But I looked up, and the quetzal bird flies at night. It roosts in the daytime. So it was about time for this quetzal bird to take off, and the bird spread its wings, and it flew over my head about 2 feet above my head. And so I got a bird's eye view, literally, of the underside plumage of the quetzal bird, and it looked like a comet. And of course, that was etched into my memory when I eventually started studying comets and understanding the plasma discharge comet model and relating this to Quetzalcoatl, the plumed serpent god of the night sky. It's very clear why they used Quetzal as the name for this bird. In the long flowing tail, it looked like a comet, literally. Okay, so anyway, I wanted to start out with this little introduction from archaeological site and weave it into the concept of space radiation. So what I'm going to do is talk about space radiation from the human perspective, because this is being covered in the mainstream science media today. Okay, so space radiation and human health, and health of plants, anything we need to exist in outer space. NASA had a program, it was called Living with a Star. This went on for decades. It was somewhat in the news media, but it wasn't really highly announced. But what it said was, how do we deal with space radiation? They had every chemist they could find, every physicist that they could find, working on this project. And you have to ask the question, if the Apollo astronauts went to the moon, way outside of our protective radiation shield, the magnetic shields, many of the shields of Earth are magnetic, and there was no problem, and they really didn't have any protection of any kind, then what's the issue? So you can answer that yourself or delve into that question. But Living with a Star was a program, look it up, if they still haven't scrubbed all of the data from the internet, but huge amounts of money dealing with this topic. There were other studies that were dealing with this same type of issue, not so much in the forefront, but I know in the military they were also very interested in this. My own personal background dealing with this, I worked in telecommunications industry for a period of 25 years, and part of that was designing electronic circuits. And part of this was dealing with and understanding space-hardened radiation electronics. So what does that mean? It's typically, abbreviation is rad-hardened, radiation-hardened electronics. And basically what you do is the gates and the other semiconductor equipment was getting smaller and smaller and smaller. And what happened down to the microscopic levels, so if space radiation, a proton, a relativistic proton, or an X-ray, or a relativistic electron hit one of these gates, it could destroy it. So what literally radiation hardened was typically to make these gates bigger. So the radiation-hardened electronics was typically done to prevent radiation from damaging electronics in outer space. Or if in, say, a conflict of some kind, maybe the opposing side would send off nuclear bombs in outer space to destroy the electronics, because especially the United States is completely dependent on space weaponry, space GPS, and all kinds of space-related telecommunications to function. And so anyway, that gives you an idea of the level of significance of this particular topic. And it's something they literally never answered. They never came to a conclusion. Now, the only people that we are told went out of this space radiation shield that's in basically low Earth orbit around Earth, the only people that we are told that went out beyond this were the Apollo astronauts. Nobody since has gone out there. During the shuttle program, the shuttle astronauts one time went up into the lower region of the Van Allen belts, this high energy proton belt and electron belt also that surround planet Earth. And I'll be talking about that. In a minute, and what it's like. I'll be showing some interesting footage here dealing with that. But what happened to these astronauts in the space shuttle was their eyebrows began to glow, and this was the type of glowing that happens if you've ever seen. It's kind of like a high school experiment that they have a Van de Graaff generator, and you have a student put their hand on it, stand up on an insulating chair like a wooden chair, and then they turn on the Van de Graaff generator, and the hair sticks straight out, and it like the electric currents come off the hair. You can see if you turn the lights off in the room, you can see the electricity coming off the people's hair because it's charging. And so anyway, that was the kind of radiation that they were experiencing. So they brought them back down and never went back since. And there were other events like that. Back in the early days of satellites, and I reference this in my peer-reviewed published papers on this topic, they talk about spacecraft charging up to, not a little bit, not a couple volts, but tens of thousands of volts. And they did not understand this. So in the mid-1990s, I was working with a team of Russian scientists from the University of Novosibirsk doing basic research. They were looking for what was causing tornadoes on the sun, and was that similar to tornadoes on Earth? I've talked about this before in this show. And so one of the issues was dealing with space radiation, because the Russians were very involved in this. And what they told me was back in the 1960s, the Russians had sent cosmonauts to the moon. And it wasn't to land on the moon, which is very difficult. It's a very difficult thing to do, to land on another celestial body, but to orbit the moon and simply come back. And the cosmonauts came back very dead, is what they told me. And of course, at that time, NASA, the Russian space program, they didn't know anything about, really in detail about the Van Allen belts, etc. But it was X-ray radiation. X-ray burns were what killed these cosmonauts. So they had no shielding. And the issue was they wanted to know what caused this, so that's why they were interested in my work, dealing with the plasma nature of outer space, the discharges of the solar capacitor, and also passing through the Van Allen belts. What was the cause of the X-rays? Now, if you look at the Apollo program radiation badges, they were, and I had the manuals to all of the Apollo program. When I was in college, we had all of the manuals of all the equipment, all of the everything dealing with the Apollo program. And the radiation badges for the Apollo astronauts were alpha and beta detectors. And they were just a badge, and they would take a reading and give you basically a reading. But alpha and beta particles are very low energy. They're not related to high energy protons, relativistic protons that you would find in the Van Allen belts. Okay, so they did not detect, they didn't know about X radiation. So there again, that begs the question, how did the Apollo astronauts go through this radiation and come back? And one of the answers that has come out of NASA, which is a false answer, through their apologists, because NASA never says anything itself. NASA has apologists or front people who talk in their stead, and so NASA never has to lie. But what they said is, though they found a hole through the Van Allen belts and they were able to pass through this hole and without any problem. Well, the Van Allen belts are changing on an hourly basis, and they can expand, they can change shape, they can change location. And so when you have a space mission that's planned months in advance, there's no way to predict. In the 1960s, they simply did not have any data on the Van Allen belts, other than they had a vague idea that they existed. Okay, so at any rate, that's just a little bit of background on the topic of space radiation, but bringing you up to date, neither SpaceX nor NASA nor any of the research that's going on in the background with the military, none of them have come to terms with dealing with space radiation. And so that brings up the question. People are talking about going to Mars. There were meetings, people sitting around chatting about how wonderful it's going to be. They're going to put on their little backpacks and walk around Mars, just like going down to the Central Park. Just really, like a fun day at the zoo. They have no clue, and the people don't talk about space radiation. So I'm going to cover this topic. By the time this show ends, you will know more about it than all of the scientists at NASA put together. And from what I understand, SpaceX, they're really, it's amazing they're talking about going to Mars, but they don't understand this issue of space radiation. Okay, so let's start here on planet Earth. And what I'm going to do is work outwards. We're going to start, us human beings on planet Earth, and look at all of the protective layers that allow us to exist on this beautiful water planet, which we're not being a very good steward for this planet. But at any rate, let's start out here. What are the protective layers? And to understand that, you have to understand, well, what's in outer space to protect us? Why do we have to be protected? And so the sun is giving off a broad spectrum of electromagnetic radiation. It's in the microwave, it's in the infrared, it's in the visible, it's in the ultraviolet, it's in the far ultraviolet, it's in X-rays and gamma rays. So these are all high energy electromagnetic radiation coming off of the sun. Our atmosphere and our magnetic fields protect us from this, and I'll be talking about that. And also the upper layer, like the upper layer of the atmosphere. In addition, there are charged particles coming off of the sun, very high velocity charged particles. Primarily, they are protons. And of course, there again, NASA doesn't want to talk about this. They believe there are equal numbers of electrons and protons, but it's simply not the case. You can actually measure it, but the problem with NASA is they think that you can measure voltages in outer space with a single spacecraft, and that's ludicrous. That's like taking a battery from a flashlight or your battery from your car and having one probe and putting it on there and trying to measure voltage. You need, the definition of voltage is a potential difference between two different points. And so you need two probes to measure voltage and in outer space. And so with the spacecraft NASA has developed, you literally cannot measure a voltage in outer space. Simply impossible, even though they'll try and announce it. But okay, the charged particles coming off the sun can reach very high energies. There can be blasts called CME, coronal mass ejections, which we get relativistic protons coming off the sun. Okay, and now this is what the space radiation is like in outer space. Plus, now when you get away from the Earth, we have all these protective layers that I'm going to talk about. But as you get farther, excuse me, as you get farther away from Earth, you are in open space. And for example, if you land on the moon is only protected behind the Earth during the full moon period for about a day or two. And then it moves out, and it's once again in the greater outer space, you might say, away from Earth. It's out of our protective magnetic field. So the moon is a very harsh environment, and as it moves around, also you go from the daytime to the nighttime. The daytime and nighttime there's not a lot of difference temperature-wise and weather-wise between night and day on planet Earth, because we have the atmosphere, and the Earth is spinning on its axis every 24 hours. So the sun comes up, in 8, 10, 12 hours of darkness, and then you get sunlight again. But on the moon, that's not the case. It goes around once every month. So if you're in the sunlight on the moon, you're in the sunlight. There's no shadow, there's no shade. And then you have these high energy particles because there's no atmosphere. So the moon is a very harsh environment, as is Mars. Okay, I'll be talking about Jupiter also, a very harsh environment. Okay, so let's come back to planet Earth. We're standing here, beautiful day out, the sun is shining. The upper atmosphere is absorbing the majority of the light that would be harmful to us. You might see on the evening weather news, they talk about the UV index. And that's an indication of how clear the atmosphere is and how much UV radiation is coming in. And that's the harmful stuff. That's the radiation that can cause cancer. The X-rays and the gamma rays and a lot of the other radiation, the majority of light coming into planet Earth is in the visible range. And that is basically, it's not very harmful as far as human beings are concerned. So anyway, the Earth's atmosphere is a big buffer that prevents a lot of that radiation from hitting planet Earth and where we live down here in the troposphere. Okay, so what happens to the charged particles? This is interesting because we have a magnetic field. We have a permanent magnetic field, which is a very small portion of the overall magnetic field. The majority of Earth's magnetic field is plasma. That's gases that surround planet Earth. And it starts in the jet streams, and the ionosphere has electrical currents. And I've talked about that before in this show. I'm not going to repeat it again. Go back and listen to earlier shows on that topic to understand those layers of the Earth's magnetic field. And then what happens as high energy charged particles come in from the sun, there's a magnetic field. This overall magnetic field of Earth extends out about 30,000 miles on the sunward side. So when the protons and electrons come in, they see that magnetic field and they split. And as I've talked about before, that causes a battery. You have protons going one way, positive charge. You have negative charged electrons going the other way, and that creates a battery. And it's one of the trigger points for our weather, electrically induced weather, which of course meteorologists know nothing about, which is strange because that is the cause of the majority of our weather on Earth, including damaging storms like hurricanes and tornadoes, cyclones, etc. Okay, so the high energy particles that are more energetic than the average particles coming from the sun can penetrate through that magnetic field. They come straight through, and that's where they get locked into this rotation. They get in a magnetic orbit around planet Earth. Those are the Van Allen belts. So when there's a solar storm, you get this rush of protons coming out. A lot of them get through the protective magnetic field, the outer protective magnetic field, and join the Van Allen belt. And some of them can come down to planet Earth, but not many. So we are really, really protected. And so the belt where the astronauts go in most telecommunications, satellites, etc., a lot of them are in geosynchronous orbit, which is a bit farther out. But the astronauts, the human beings in outer space, are in this protective low Earth orbit region around planet Earth. So you can hang out there all you want, and you're still protected. That radiation belt, the Van Allen radiation belts, are outside of where you are, and they're capturing the majority of the protons, the high energy protons, the very high energy protons that come off the sun. And then the electrons do the same. There's a smaller but active electron belt in the radiation, the Van Allen radiation belts. So that gives us a lot of protection here. However, if you want to go through the Van Allen belts, you have a little bit of a problem, because what happens, those protons and electrons hit something metal, primarily metals, and they cause X-rays. And this is why the Russians were very interested in my work, because it finally explained the source of X-rays that killed their cosmonauts. And so once again begs the question, well, how come NASA went to the moon with various Apollo flights and never had a problem, and then they come along and they open up this Living with a Star program trying to figure out how to deal with space radiation as being a necessary milestone before going into outer space and going farther in outer space than low Earth orbit. Okay, so that's where we live. Now, if you're going to go to the moon, for example, I'll add one point here. Another place where radiation comes follows the magnetic field lines down to the north and south pole of Earth, and that's where the auroras are. There was a group of scientists living at the South Pole, and there was a big solar storm that came along, and the radiation followed the magnetic field lines in to the South Pole, and they all were getting cancer. There's a story that a woman doctor who was there they showed a picture. She had a tumor here on the side of her chest, near the arm, and she had to operate on herself, and this tumor grew overnight because of the radiation. And this is what happened with the Russian cosmonauts. And so it can affect people, but not many people are at the South Pole. Not many people are living on a long-term basis. So they had to fly in under extreme difficult conditions to get these people out of there. And so they found, a pilot and planes to go pick them up and bring them back to safety. But in the winter, when you're there, in the Antarctic winter, when you're there, you're kind of there for about 6 months till they can get a plane in and get you out. But they had to make an emergency run to get these people, and that's because the radiation follows the magnetic field lines at the poles. But once again, we live in the middle of this magnetic field on planet Earth, so most people are protected. If it were not for this magnetic field protection, we would have to have a couple inches of lead shielding walking around on planet Earth. So we are very, very protected. Now, just an insert here, when you go back to the Mayans, they had a Passover ritual exactly like the Israelites. Remember that Moses, leaving with the Israelites out of Egypt, had the Passover. Well, very well documented. And so what they did is they had to seal their huts with mud so the air could not get in or out. And they had to have all of their food in that hut for all the people that were there, and they painted lamb's blood over the door so that if somebody came there that was like, don't even knock here because we're not going to open this door. And they had warning of this event. Okay, so anyway, I'm not going to go into a lot of detail, but that was related to events in the atmosphere. The Mayans had the very same ritual. There are tribes in, I believe, in North Dakota that, interestingly enough, have blonde hair and blue eyes who also have a Passover ritual. And the reason for that was because of conditions, atmospheric conditions. I'm not going to go into a lot of detail on that, just an aside note. Okay, so now let's imagine that we want to travel out into outer space. We want to go away from Earth and through the Van Allen belts. I've developed a mechanism to mitigate the radiation, but I'm not giving it to the military. I'm not giving out to anybody because it's they're militarizing outer space. That's one of the big issues that I have with any of the outer space programs today. They're militarizing outer space. And it's like if one side does it, then the other side has to, and there's this escalation. I'm just tired of space agencies turning into military establishments. Okay, so anyway, that's another issue. But there is a way to get through the Van Allen belts, and it's like many things. If you understand it, it's very easy. If you are ignorant about such things, then it's going to be impossible for the scientists at NASA to figure this out. They've put all of this time and effort and manpower, and they can't figure it out. So, okay, be that as it may. Now you're going to deal with radiation in the larger solar system, because as soon as you get out 20, 30,000 miles away from Earth, you are in free space. You're away from Earth, you're away from the protective magnetic field, you're certainly away from the protective atmosphere. So you have to duplicate everything that is going on our planet here. And there are ways to do that. I won't give, there are other technologies like this in other fields, not related to outer space, and for mitigation of certain effects that happen to other human technologies, I'll just say it that way. And people have figured this out over time, but they have not conquered the space radiation issue yet. They don't even know the questions to ask, let alone how to answer them. Okay, so if you get away from Earth, now you're in free space and are discharging the solar capacitor. This has been observed with, for example, satellites. Satellites, one satellite observing another satellite, that it forms a cloud. There's an experiment that NASA did where they let a barium cloud out from a satellite, and all of the little chunks of barium started forming little comets shapes around them and became highly charged. And they couldn't figure out why this was. Well, even the smallest particles are discharging the solar capacitor. And so this is a form of space radiation, and once again, the electrons, if you look at a comet, for example, which is a perfect example, could be small, it could be large, could be very large, nucleus, discharging the solar capacitor, the primary charge carrier is in the form of electrons coming out from the sunward side. As soon as those electrons hit the cloud of gas and dust around the comet nucleus, they start creating X-rays. That's why you see X-rays to the sunward side of comets. They're Bremsstrahlung X-rays. Bremsstrahlung is a German term for braking. And so anything in outer space, including a spacecraft, would be creating Bremsstrahlung X-rays. And therefore, accumulation of that type of X-ray radiation is deadly. And if, say you had a spaceship, and you had all of your plants there, your food, you were growing food, you had food stored, that X-ray radiation would destroy it, would destroy the genetic nature of whatever it was, including the people. If you had animals or birds or mice, experiments or whatever, you're going to have this issue in outer space. So to go to the moon, if you're going to Mars, it's going to be the same issue. Extended periods of time in that space radiation environment. And so the reason I showed you this article, or talked about this article at the beginning of this show, was because only at the very end of the article did they even breach the topic of space radiation. They're talking about all of these other issues dealing with zero gravity or whatever. Zero gravity is something that's very easy to fix. You just have a spinning spacecraft and it gives you an artificial G. And very simple to fix. But the other thing about outer space is they want to duplicate the environment of Earth. There are millions of factors that are present on planet Earth that make it possible for us to live here. So just providing an atmosphere of certain percentage of oxygen, just providing the same food that you eat here, in atmospheric pressure, for example, that's just a couple of the millions of factors that allow you to live comfortably on planet Earth. And they're not anywhere near resolving this or discovering all of the factors that can that affect human beings on planet Earth. To put them in a spacecraft and simulate all of these on a daily basis is, I liken it to, for example, the Boy Scouts going camping. Say that, okay, you're a Boy Scout troop and you're going to go camping, and you go to the camping store and you buy all the right stuff. You got, okay, now you're out there camping, and all of the things you think you need. And all of a sudden there's a disaster and you have to stay longer. Well, you're dependent completely on things that you brought from planet Earth, from the camping store. And it's the same thing with travel in outer space. If people are going to go to Mars, they're going to try and take everything they need. And you know, there's a good movie with Matt Damon, I'm sure most of you have seen it, talking about the difficulties of trying to travel to Mars. And of course, they save Matt Damon at the end of the movie. But taking all of the supplies, going to Mars is very different than going to the moon. Going to Mars is a very difficult thing to do, plus landing, plus all the fuel you have to take, plus having redundancy for everything. What amazes me is they're not going to the moon again. They're trying to go straight to Mars. And it's like, you can't run before you can walk. Mars is a whole different program. It's much more difficult, much more long-term. And let me just make it very simple. If you were going to go to Mars, you would have had to have tested all of the equipment and all of the systems and all of the support that you're going to use, at least in low Earth orbit. And they haven't done maybe a minuscule amount of work on this. So and then you would have to go to the moon many, many times, landing on the moon, coming back, bringing all of the supplies you need. And just imagine if, let's take another example in history, that the pioneers they're going across the Great Plains and settling the West. They brought with them a certain amount of equipment. They might have had an axe. They may have had the, a bison, or not a bison, but a big steer. Or they might have had a couple of horses or something. Very rudimentary equipment where they could fix a wagon wheel en route. And this is what they went with. But once they got there, their supplies were going to run thin. They had to move in and live there based on what was available at the location. That was one of the big difficulties with the pilgrims coming to the United States. Why many of them failed is because they're in a completely new environment. There was winter to deal with. That's why we celebrate Thanksgiving. It's the first winter that they had enough food, and they knew they had enough food to survive. But going to Mars, there's no store on Mars. There's no place to buy anything, no matter how much money you have. And so all of this would have to be tested extensively before you ever thought about heading out to Mars. And none of this has happened. So it's really a long ways away. So it really amazes me when people are talking about going to Mars and like going for a little hike on Mars. It's going to be a long time in the future till they're actually ready. Okay, so now let's go out to Jupiter. Jupiter is another story in itself because Jupiter has, if you think Earth's Van Allen radiation belts are dangerous, they are nothing compared to Jupiter. And I've talked before about Jupiter and Jupiter's magnetic field. NASA cannot tell you where the Jupiter magnetic field comes from. What causes it? What's the source of the magnetic field of Jupiter? Well, they can't tell you. And the situation is it has a permanent magnetic field and an extensive plasma magnetic field, just like planet Earth. And the core magnetic field is probably singular atomic hydrogen in a probably like a crystalline form, because the hydrogen atom has a permanent magnetic field. So if you have a singular atomic hydrogen, you can form a magnet just like you can with iron. Okay, so anyway, be that as it may, the issue with Jupiter is you have these intense magnetic fields and you have a proton wind coming off the surface of Jupiter. It was actually measured by the Voyager spacecraft and published in the science articles written by Brad Smith, the leader of the Voyager spacecraft missions to Jupiter back in the like 1980 timeframe. So Jupiter would be an extremely harsh environment to visit with a manned spacecraft. They've had, of course, the unmanned spacecraft visiting Jupiter and Saturn. And okay, now if you were to traverse the solar system going from Jupiter then out to Saturn, the next planet out, Saturn is smaller but it has even more intensive radiation situation than Jupiter for its size. And then if you wanted to go farther out in the solar system, you would go out into the Kuiper Belt, which is basically a region of dust and gas which surrounds our solar system. And after that, as we know now, the Voyager spacecraft finally has broken through and into the intergalactic wind. And there you have electric currents that flow between the stars in the galactic arms. And I've talked about that before on this show. So these are the regions of radiation that you have to deal with, not to mention all of the other issues going on in outer space for life support, all of the things you would need to be successful in outer space. Okay, on to another topic. I promised this on an earlier show, and now is a good time to insert this, dealing with Tesla. Nikola Tesla, on his way to England when he disappeared. They told us he died. I don't believe the story. I believe they sequestered him. The only person that really said he died was the maid in the New York hotel where he was staying. And the next day, people went in and cleaned out all of his records. And now it's known that he had spies, literally from the intelligence agencies, down the hall, monitoring his every move and monitoring everything he did. In fact, it was known that he had carrier pigeons to try and get messages out from, because he knew he was being basically tapped. But the story is, the real story, He was on his way to England. This is in the midst of World War II, 1944, the height of the Germans trying to invade England, the height of the Allies building up the assault on Normandy Beach, etc. And he wanted to sell a technology which he called the death ray to England. And all of a sudden he disappears. And they claim that he died. So maybe he did, but I question that story because of the extenuating circumstances. But I said that I would tell you how the death ray works, and I've covered this on previous shows. The radio show that goes back 24 years, I've talked about this and also in other venues. But at any rate, here's what the death ray was. Now, the concept, we think of a ray as something like a laser, where you zap something and it falls out of the sky, an airplane. But remember that in early 1900s, Tesla had built his Wardenclyffe Tower. And basically what it was a device to tunnel electrically through the atmosphere. And I've talked about this before, how the Earth's atmosphere is a dielectric, and it's a dielectric in the capacitor between ground and the ionosphere, which has charged belts moving around. That's part of our magnetic field. That's part of Earth's magnetic field. It's one of the layers of Earth's magnetic field. So the Earth has its permanent magnet, which is in the crust and mantle of the Earth. Then the next layer out are these series of electrical bands that move around Earth's. And so the end result is that Tesla learned how to tap into this and drill an electrical hole and garner electricity, and that's why they tore it down, the Wardenclyffe Tower. The official story was they were worried about it getting into the hands of the Germans. Well, why would that be a threat to anybody, given the standard story of what the Wardenclyffe Tower was? That was simply to distribute electricity through the air, which is not what it was. Okay, so anyway, the Tesla death ray was a series of Wardenclyffe towers that you would build along the coastline in England, like the White Cliffs of Dover and that whole coastline, southern England, where the Germans would come across with their airplanes, or any place. And this would have, his death ray would have effectively shut down the air war on all sides. As soon as it got into the hands of anybody, the air war would have been obliterated. And so what happens is you set up the Tesla towers, the Wardenclyffe type Tesla towers, on the brink of discharge. And this is exactly like the backyard bug killer. If you look at what that does, there's two electrical plates. The outside one is at ground, so you don't get zapped yourself when you handle this thing. And then the inner plate is a high voltage. And then you have a light in the middle, and the bug flies in, brings in the ground potential with him, and then discharges those plates. And the discharge always occurs where the bug is, right? And that's the same idea, that you would have these Wardenclyffe towers set up all along the coastline, and as the airplanes would come in, just like the bug zapper, they would be enough to discharge the vertical electric field. It would zap them and they would fall out of the sky. And so that was the death ray. Tesla was on his way to England to sell it to the British, and he was stopped by the US military. So they were at it way back then in basically the war business, keeping the war going. And that possibly could have shut down the World War II much sooner. Tesla was a pacifist. He was against the war, and he invented this to stop the war, basically. And it would have basically stopped the German flights into England. They simply would have stopped them, and they could have built these Wardenclyffe towers basically overnight and powered them with the original way the Atlanteans powered them was with seawater batteries and Schmidt triggers. So at any rate, I wanted to get that into the show to talk about the Tesla death ray, what it really was. And in a sense, it's a ray, because once these discharges start, where the airplanes are flying through this field of Tesla towers that are set just to the point where they're ready to discharge, but not quite. It's the exact same thing as the backyard bug killer. And so as the planes would fly through, they would discharge the vertical electric field. It would be a tremendous jolt of electricity that would literally take the plane out of commission. They would crash into the ground, and it would have ended the air war of Germany coming into England. But Tesla never got there. And that's why I say it's the circumstances, when you understand what was going on at the time, and this was 1944, remember, still in at that point the World War II was raging in Europe. Of course, the war in the Pacific was raging also. And of course, at that time, the Manhattan Project was underway. All of this was underway. But Tesla had a technology that would eliminated the air war, especially if he could have sold it to the English. And I estimate that it would have taken them about 6 months to actually build this array of Wardenclyffe towers and power them. So, at any rate, I wanted to get that in on a show, and this was a good section of time to include that. Take a second to check out the webpage, jmcannyscience.com. The short URL is jmccsci.com. My latest release, eDVD, Eclipse, the New Cosmology, goes through all of the things that you have to know to understand this radical change that is really taking place right now, and with the Big Bang simply going away overnight, something I did not expect. We knew 50 years ago that the Big Bang did not work, but finally the James Webb Telescope data is putting it to rest. Go visit the webpage, jmccsci.com.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern, right here on the Bold Brave TV network, powered by B2 Studios.